another couple of minutes to let people. My name is Professor Aaron Clausette. I'm an associate professor in this Department of Computer Science. This is a special edition of our colloquium series. It will be first of all, a half colloquium slot. We'll have one 30-minute talk today. And we will be featuring one of our very own students. So Nick LaBerge will be giving a presentation today. Let me just say a few words about Nick, and then I will turn it over to him. And before that, since we are doing this over Zoom, if you have the ability or feel comfortable turning on your camera, please do so. I am 100% sure that Nick would appreciate being able to see some faces as he's speaking, to see, engaged looks or not or whatever. So thank you for that. Okay, so Nick is a PhD student in our department. He is from Tacoma, Washington, and he did his undergrad degree in physics at the Claremont McKenna College. And he is advised by Dan Larimore and myself. And Nick, do you want to go ahead and share your screen? And he is going to give a presentation today titled Prestige, Representation, and Inequality Across the Subfields of Computing. If you have clarifying questions, please feel free to ask them during the talk. Otherwise, hold your questions till the end, and we'll have some time for Q&A. So thank you, and take it away, Nick.
Great, thanks for the introduction. Before I get started, I want to say it's an honor to be presenting to y'all here at the colloquium, and that a part of the way through the talk, I'm going to ask for some audience participation, so be ready for that. Despite a continued emphasis on broadening participation in computing, several demographic groups remain underrepresented. Women represent roughly half of the United States population, but only 21% of tenure-track computing faculty. And Black, Hispanic, and Indigenous people represent roughly 34% of the United States population, but only 5% of tenure-track faculty in computing. Moreover, race and gender are not mutually exclusive, and people at the intersections of multiple underrepresented identities, like women of color, are particularly underrepresented in computing. So past work has sought to understand why some fields are more diverse than others. Some explanations can be categorized as pushes. One study quantified differences in what is called expectations of brilliance by conducting a survey of faculty across a range of disciplines. To measure expectations of brilliance, they asked faculty questions like, being a top scholar of their discipline requires special aptitude that can't be taught. And the reverse scored question, when it comes to their discipline, the most important factors for success are motivation and sustained effort. Raw ability is secondary. They hypothesized that because there are cultural stereotypes upholding the false notion that women are less likely to possess raw innate talent than men, women will be less prevalent in fields with high expectations of brilliance. They indeed find a correlation between emphasis on brilliance and women's representation. Faculty in computer science tend to place relatively high emphasis on brilliance. Other explanations can be categorized as polls toward research topics. A recent study looked into the relationship between faculty identities and their research topics. They applied a topic model to a huge collection of publications in the social sciences. And for each inferred topic, they found the proportion of first authors belonging to different racial and gender identities. Plotting these topics on an axis of proportion first authors by race, and in this case, proportion of Black first authors, and by proportion of women first authors on the vertical axis, they identified homophily between faculty identity and topic choice. For example, publications relating to Africa and racial discrimination were particularly likely to have Black first authors, and publications relating to gender-based violence and learning were particularly likely to have been first authored by Black women. Both studies that I just described attempt to account for demographic heterogeneity across fields and topics. Variation in who studies which topics at the subfield level in computing is particularly interesting to me because it may be shaping the diversity of the field as a whole. This is because most faculty are hired via searches that focus on a particular subfield of computing. For example, our computer science department is currently running a faculty search specifically in cybersecurity. A natural question is, how does our department's choice affect our probability of hiring underrepresented faculty? And so there are three main questions that motivate and outline this talk. Do subfields vary in demographic composition? How are subfields represented across computing departments? Where are we going as a field, and what can we do? To answer these questions, we use the employment records for 6,882 tenure-track faculty at United States computing departments who were faculty at any point between 2010 and 2018. We start out with faculty names, institution and department, and the year and institutions of their doctoral training. This data set was obtained under a data use agreement with Academic Analytics Research Center, or AARC. Using name-based gender inference tools, we match faculty to the genders that are culturally associated with their names. We directly asked faculty for their racial and ethnic identities in a faculty survey, in addition to information relating to their socioeconomic status, and I'll talk more about this survey in the next slide. We infer faculty subfields using a semi-supervised topic model, and I'll outline our approach in more detail in a few slides. Finally, we infer prestige of computing departments using a faculty hiring network-based approach introduced by DeBacco et al., which is highly correlated with other measures of prestige, including the US News World Report rankings and the minimum violations ranking. While a person's gender and a person's name are often closely associated, there are weak or non-existent name race and name SES associations. So we conducted a faculty of survey to directly ask for information on these axes. Our survey yielded 1,139 responses. So we only have race and SES information for a subset of computing faculty. This survey also allowed us to compare self-reported faculty gender identities with the genders inferred using faculty names, and we found 97% agreement. And so now we have faculty demographic information, and we can return to the question that I raised earlier, which was, how might the choice of which subfield to hire in impact our likelihood of hiring underrepresented faculty? And so to answer that question, we still need a way to know which subfields that faculty engage with. To infer faculty subfields, we first pre-identify the taxonomical structure of computing using our own domain knowledge with the help of specialists in areas that we were less familiar. We identified 8 subfields, including theory of computer science, with each subfield containing more fine-grained research areas. Then, using titles of papers from journals and conferences dedicated specifically to each research area, we extract words that are suggestive of each research area as measured by mutual information. We link faculty to their publications in DBLP. Then we assign publications to computing research areas using the semi-supervised topic model that implements the words that we extracted for each research area to guide the clustering of publication titles to be more aligned with our taxonomy of research areas. Finally, we assign a distribution over subfields to each faculty in proportion to their publications. And so while each research area is a different topic with different word associations, we conduct our analysis at the subfield level because faculty hiring tends to take place at this higher level. And so we can externally validate our topic model's subfield assignments on multiple levels. Here, we open the hood of our topic model to check which words are highly associated with each research area. So here's where I'm going to ask for some audience participation. Can people in the audience unmute to guess which computational learning research area is associated with these set of words? It's not a trick question. It should be easy.
Computer vision.
Right, exactly. And then what about the second set of words?
Machine learning.
NLP.
I heard NLP. Great. And so we can also look at faculty distributions over subfields based on their publications. Can anyone guess which junior faculty at our department this first distribution belongs to? A little trickier. So most of their publications are in theory. I'll give you guys like 10 more seconds, then I'll just reveal the answer.
There are some guesses in the chat.
Oh, okay. Anyone right? I know you know the correct answer. Okay, well, I'll just say maybe someone got it right. It's Josh Grotchow. And then I don't know if there were any guesses in the chat for the second distribution. It's a senior faculty here at the CU department. And it is Lisha Pellin, who mostly studies human-computer interaction. And so we can also look at a level higher and ask which departments are the most specialized in each subfield based on faculty composition. We find that the department with the highest fraction of human-computer interaction faculty is University of Washington's Department of Human-Centered Design and Engineering. And the department with the highest share of faculty in computational learning is reasonably CMU's machine learning department. So now that we finally have faculty demographic information and subfield information, we can compare women's representation in each subfield to reference populations, including the US population and the population of CS PhD recipients. So most current computing faculty received their PhD sometime over the past 40 years, but over that time period, the demographics of these two populations have changed substantially. As a result, a simple comparison of the diversity of current faculty to the diversity observed in the reference population at some particular point in time would be misleading. To address this issue, we constructed a time-adjusted reference population for each of these that is based on the demographics for the years that professors received their degrees. The first thing we notice, without even considering faculty representation, is that the representation of women is substantially depleted among computing PhD recipients relative to the US population. Looking at faculty in theory, programming languages, numerical and scientific computing and systems, we observe further depletion of women's representation. And turning to look at the remaining subfields, we find that women's representation in two subfields, human-computer interaction and interdisciplinary computing, actually exceeds the proportion of women among computing PhDs. So here we quantify depletion in women's representation among PhD recipients and further depletion among faculty in some subfields. But it's important to note that our research does not untangle the causes of these depletions in representation. And so ongoing work has presented a number of mechanisms which may drive women's underrepresentation in computing and other STEM fields, including problems relating to hostile climate, sexual harassment, unequal career impacts of parenthood, and the expectations of brilliance hypothesis that I discussed at the start of this talk. And so next, we looked at the socioeconomic representation of computing faculty by subfield, once again with adjusted reference populations. We used faculty's self-reported parents' highest level of education as a simple measure of socioeconomic status. We found that faculty with a parent with a PhD are substantially overrepresented among faculty, both with respect to the general US population, indicated by the black dotted line, and with respect to people who earn computing PhDs, indicated by the gray dotted line, or the gray solid line. Looking at lower levels of parental education, faculty representation tends to decrease. We find that first-gen college graduates are particularly underrepresented among faculty. However, we do not find significant variation across computing subfields with respect to socioeconomic status. What we do find is that faculty tend to come from highly educated families and particularly from parents who have PhDs. Other work has demonstrated that this is true across many fields. In computer science, faculty are up to 26 times more likely to have a parent with a PhD than the general population. Across many surveyed fields, faculty were 22.2 times more likely. Once again, this work does not identify the causes for these differences in representation. However, the observed reproduction of high educational achievement across generations basically raises important questions for future research. Finally, we can look at the racial representation of faculty across computing subfields. We don't find substantial variation between subfields, but we do find notable patterns of enrichment and depletion among computing PhD recipients. In particular, the representation of white faculty is enriched among PhD recipients relative to white representation in the US, but then white representation is mildly depleted among faculty relative to PhD recipients. Asian PhD recipients are overrepresented with respect to the US population, then further enriched among faculty in all subfields. On the other hand, Black, Hispanic, and people marking other are underrepresented among PhD recipients, then remain underrepresented as faculty without much enrichment or depletion at this second stage. This suggests that efforts to increase representation for Black and Hispanic faculty may need to focus efforts before the stage of faculty hiring. These plots do not illustrate how people at the intersection of multiple identities may be especially underrepresented. Black, Hispanic, and Indigenous men make up 3.3% of the men in our sample, while Black, Hispanic, and Indigenous women make up only 0.2% of the women. And while our research does not shed light on the causes for these differences in representation, there's a large body of research linking racial underrepresentation in higher education to issues of systemic racism, which often intersect with socioeconomic status. For instance, in 2016, the Pew Research Center estimated that the median wealth of white households was 10 times that of Black households and 8 times that of Hispanic households. So do computing subfields vary in demographic composition? Yes, they do with respect to women's representation, but not along other axes like racial and socioeconomic representation. Now, how are subfields represented across computing departments? We observe that departments vary in their representation of subfields. Systems faculty tend to make up the largest share of a department, but representation of systems within departments can vary or range widely. There are some interesting outliers which specialize in certain subfields, like the machine learning department at CMU. So knowing that departments can vary substantially with respect to faculty subfield composition, I wondered, do the faculty compositions of departments at the most prestigious institutions vary from those at the least prestigious institutions? As someone who studies science of science, this is a natural follow-up question, as prestige plays a major role in shaping several aspects of academia, including the production of faculty and the diffusion of scientific knowledge. Prestige can be measured in many different ways, including the US News and World Report rankings. However, such rankings are often criticized for being based on subjective criteria and for largely measuring inputs to academic institutions like endowment or donations, rather than outputs like student success. To overcome some of these problems, we use a data-driven ranking based on hiring networks between institutions. We construct a directed faculty hiring network where nodes represent institutions and edges represent a hiring event where an institution hires another institution's PhD as faculty. Then we rank the nodes using the spring rank algorithm, which essentially ranks institutions such that high prestige institutions are more likely to send their graduates to be faculty at lower prestige institutions. In the end, this ranking turns out to be highly correlated with the US News and World Report rankings and other authoritative rankings. The prestige hierarchy is steep, such that the top 50 institutions trained 72% of all current computing faculty. And for those who are curious, CU is ranked 51st among 269 PhD granting computing departments, but we will always be #1 to me. So how does the concentration of faculty in each subfield vary across the prestige hierarchy? To gain insight into this question, we plotted faculty representation across the prestige hierarchy. We find substantial variation in representation. For example, programming languages faculty are 5.9 times more likely to be found in the most prestigious departments than in the least prestigious departments, while software engineering faculty are only 2.3 times more concentrated at high prestige departments. Next, we asked, how does a subfield's representation among top departments relate to its share of women faculty? Plotting a subfield's fraction of women faculty against the fraction of faculty in that subfield at the top 50 ranked institutions, we found that subfield representation among top institutions is negatively correlated with women's participation. Because the most prestigious institutions train the majority of future faculty, the underrepresentation of gender diverse subfields among these institutions may act as a structural barrier to gender diversity of computing as a whole. Finally, where are we going as a field and what can we do? Using faculty degree years as an approximation for when faculty started their tenure track positions, we can plot approximate changes in women's representation over time by each subfield. At current rates, 4 subfields, theory of computer science, numerical and scientific computing and systems, lag the other 4 subfields in representation by an entire 25 years. That's a really long time. For reference, I've been alive for just over 25 years. But on a hopeful note, women's representation in computing is increasing across all subfields. Our paper sheds new insights in the context of efforts to diversify computing. The differences in diversity and prestige that we find across subfield structure, the subfield structure of computing, suggest a simple departmental strategy for enhancing our probability of hiring women faculty, and that is to increase hiring in the subfields with greater gender diversity, such as human-computer interaction and interdisciplinary computing. Such a strategy would have additional impact if it were implemented by departments near the top of the prestige hierarchy, because their faculty tend to train the majority of future computing faculty. A subfield-focused hiring strategy is unlikely to increase racial or socioeconomic diversity, as we found that these faculty characteristics do not appear to correlate with subfield in our sample. Other approaches will be needed to improve representation along these dimensions, and our findings suggest that these should include interventions that increase representation among PhD recipients. So there are some limitations to this research. Our results do not identify any specific underlying mechanisms for differential representation across subfields. It would be great if future work could dig into the causal mechanisms behind the observed differences at the subfield level. Our name-based tool annotates names as being only male or female. This is a limitation because in reality, gender is not binary. Our study also lacks a robust intersectional analysis due to data limitations. Finally, our data does not include tenure track faculty. This is a limitation because non-tenure track faculty, such as teaching faculty or research faculty, makes substantial contributions to the training of future researchers and to innovation. I hope that future work will be able to overcome some of these limitations. So to recap, in this talk, we have found that subfields do vary in demographic composition along the axis of gender, but not along the axis of socioeconomic status or race. We found that subfields vary in representation across computing departments, and that subfields with more women tended to be less represented among highly prestigious departments. Finally, we tracked gender representation over time and found slow progression towards equitable gender representation among computing faculty, but progression nonetheless. And I offered one possible strategy to expedite gender diversification in computing. I'd like to thank my wonderful collaborators, the funders of this research, and several CU faculty who provided helpful feedback regarding the taxonomical structure of computing. Finally, this work has been uploaded to the archive, where those who are interested can look into the details of this project. I'm excited to answer any questions and have a conversation about this presentation. And so thank you all so much. Yay. I saw Claire's hand, so I can just take that one first.
Yeah, congrats. Wonderful work and talk. Very clear. I just wanted to linger a little bit more on the figure that, can you go back to your last slide? Actually, I think it was even repeated there.
This one.
Page through the animations, because I think it's towards the bottom on that one.
Okay.
Yeah, this one.
Right.
The middle bottom. Can you just walk us through that a little bit? What it's showing? It like
yeah, of course.
Learning an
sure, I'll see if I can. I might be able to find the larger. Wait, so the one with showing the distributions among departments.
The one next to it, the middlemost one.
Okay, I think I can take us to a larger version. So what we're looking at is each plotted point represents a subfield of computing. And so for example, this is theory of computer science, has 42% of its faculty, like 42% of theory of computer scientists are at the top 50 institutions or among the top 50 most prestigious institutions. And it has roughly 11% women, if that makes sense. And so what we find is that subfields that have more women tend to be less represented among the most prestigious departments. Does that make more sense?
ML be an outlier there, that green box?
Yeah, I mean, it's a little bit of an outlier considering that it is pretty well represented at top institutions compared with human computer interaction, interdisciplinary computing, and software engineering. But it does have greater gender representation.
Interesting. Thanks so much.
Yep. Let's see. I can't see any hands, but if anyone has a question.
There's a question in the chat.
All right, let's see. So Nick, on the topic of Brilliance and faculty candidate hires, you've considered / come across, have you considered / come across any research on Brilliance as a social construct? What do people mean? Yeah, I think that Brilliance paper is really interesting. And so I'm going to try and go to where. So these are the questions. They ask a few questions similar to this about, to try and come up or construct this idea of expectations of brilliance and what's required to succeed in a field. And so in some fields, people tend to believe that if you work really hard, you can succeed. Whereas in others, it's more often that people will believe you need to be born with some raw innate genius talent in order to thrive in that field. And interestingly, what we find is that there are correlations between women's participation and fields expecting this brilliance. Hopefully that helps answer your question a little bit. So let's see. I saw another question. Is there a similar study analyzing CS PhDs opting for industry jobs? Right. So that's a really interesting point. I'm going to go to, where do I want to go? I'll go to this plot. And so one thing we kind of wondered about here is, okay, so we see that this enrichment of white people among PhD recipients relative to the US population and then a depletion after that stage of achieving a PhD. And we wondered at what's causing that, what's going on. And this is pure speculation, but one theory is that potentially white PhD recipients are more likely to go on to opt for industry jobs than other racial groups. And that could cause this observed depletion here. But let's see, is there a similar study? I haven't seen any similar studies, but I think that'd be a great avenue for future research. Thanks. Any more questions? So would the trends look different if it were students, and how would it change when they go onto industry and academia, et cetera? Right, so that's a good question. And I think that's kind of pretty similar to what I just spoke to. The CRA, the Computing Research Association, did publish this data set, or I guess a data summary showing PhD graduates by topic and their gender representation by topic, which do kind of line up with our findings on the level of faculty. And so, maybe there's a future research project in looking at which graduates by subfield are more likely to go to which positions, whether it be in the industry or in faculty positions. Hopefully that answers your question a little bit. And then maybe I'll take one more question. Are you guys thinking to extend this research to European universities or maybe worldwide level? That's tricky. So we have this awesome data set that we got through this data use agreement with academic analytics. And so when data is available, I'd be really excited to look at differences between, nations and how the academic systems vary. I suspect they vary a lot, but yeah, we don't have any immediate plans to do that. Okay, I see one more question and I'm tempted to take it, and then I'll let everyone go. So is it the case that the highest subfield fraction of women aren't from the top 50 institutions because they are highly involved in the area of HCI? Can we conclude that if the most prestigious colleges hire more diversely, the situation will improve? I don't think we can necessarily conclude that. We don't have like the causal link, but I suspect that would be the case. So if the most prestigious institutions start hiring more in a subfield, there will be maybe more faculty trained in that subfield. And I think top 50 institutions are often trendsetters for the field. And so, yeah. Thank you guys so much. I really appreciate you listening. It's really exciting for me to be able to give this colloquium talk. Yeah.
Thank you, Nick.
Thanks, Nick.
And that concludes our colloquium for today. And I think there'll be another one. So check your email for next week or the future.